I was talking with some of my friends in Tesla. A full set of dies for one of the first cars they made was $120 million. With our process, we realized, okay, we can get these robot sheet formers to form sheet metal without any need for die. Two robots come from two sides, start pinching the sheet. As you expand, one of the robots starts giving it shape. I would love to live in a world where any great idea can become real. I'm a car guy, so I used to make cars panels with hand. We announced a collaborative work that we're doing with Toyota, enabling people to design a car that's uniquely how they want it to look like. If we make a company that enables freedom of expression in physical world, that's going to be a massive company.
Today, I have the pleasure of sitting down with Ed Mehr, and he is the co-founder and CEO of Machina. And Machina is basically building these robots that allow you to form metal in a very unique way. We're sitting next to the, I think, third or fourth iteration of the Franz von Holzhausen. I don't know how you describe that. But anyway,
Franz Solo?
Yeah, Franz Solo. How did that happen?
Yeah, no, so we were going to a conference, and the organizers of the conference say, hey, in this conference, we want to really honor Franz for all the contribution he has had to
He's
the
like
auto
the
industry.
Chief designer of Tesla.
Chief
right?
designer of Tesla.
Yeah.
And he's a great guy, fantastic human being. And it's like, we want to come up with something that, really captures him in something that's permanent.
Mm-hmm.
And, it matches his contribution into industry. Obviously, he's built all these amazing metal machines, right? And I was talking to him at the time, to the organizer. I was like, hey, we've been doing a lot of sculpture, so maybe we can do something around that. And then it was like, yeah, that's a great idea. And then we chatted a little bit, and the idea of Han Solo and Franz Solo came about. So it shows Franz being kind of memorialized in a medal. There's a picture of us giving it to him as a gift, and I think he looked happy about it. I know he was being nice, but it's a pretty massive, basically, sculpture.
When you decided to do this in the first place, like, what does that process actually look like, from just scanning someone's face or body to actually having it, made in metal?
Yeah, this is kind of comes down to the core thesis of Machina. Can you turn ideas into physical reality as fast as possible in the most automated way? Right? So it starts from a design. We feed the design to our software system. Our software comes up with a rough set of instructions for the robots to manufacture the part. Mm-hmm. Then we send those instructions to the robot. The robot looks at the sensor data every 4 milliseconds and then make adjustments. So you have the rough instructions, but online, the robots are constantly making adjustments to make the accurate part in real time. So there's both like an offline component and a real-time component. And then at the end, once you're done, the robot scans it so we can look at the final result and compare it to what the design was, make any adjustments we need to do or not. The robot can come up actually with a set of adjustments to make the part more accurate. But the whole kind of tool chain from design and idea all the way to the final physical product is part of our technology stack.
You mentioned when we were just walking around that it used to take like more than 25 attempts before you got a part or, that was made correctly. How did that start, and how has that kind of evolved over time?
Yeah. So what we're doing is something pretty chaotic, right? We call these systems robo-craftsmen mm-hmm. because the idea is that they can operate like a human blacksmith or a craftsman. A set of robots, they can pick up different tools, then come up with a set of process parameters and sequence of operations to turn an idea, a design, a CAD, into a final product. But a lot goes into that. As a human, we're constantly looking at the piece, making adjustments, changing our course of action. So it's a pretty chaotic, high variability kind of process. So we needed to tame that, right? Mm-hmm. So early on, we didn't have any data to figure out how we're going to tame this process, right? That's one of the challenges.
Going from scratch.
Exactly. In robotic application is that there's not a whole lot of real data out there for you to use to be like, okay, how am I going to form sheet metal like humans would with a hammer? So we first built the machine, and the idea was like a human will guide it, right? So we come up with some kind of heuristic set of parameters, let the robot do its thing, we look at the results, we make adjustments, go another trial. So basically it was just human in the loop, but instead of human picking up a hammer himself, the robot was picking up the hammer and doing the work. And we constantly would look at the data and make adjustments. So early on, one of our early parts we got was from SpaceX. It was a shroud for a rocket engine. And it took us 25 different trials to even get it right? Even ballpark of right.
And what were all the like issues during those 25 trials?
Like one trial, he comes in and the part tears.
Mhm.
We just apply too much force in one area and the part tears. Another, you're going through and suddenly the part in the middle of the forming buckles because of the stresses. Another one, you start getting really bad surface quality, right? It digs into the material and it just doesn't look good. And then even if you get the part roughly correct, then it's just inches off of CAD, right? Because the sheet moves in all kinds of unpredictable way as we're forming it. So a whole bunch of challenges there. So we slowly start adding more and more tool so that the human operator can kind of make adjustments that are necessary in a more direct way. And now we're averaging around 4 or 5 trials. The goal is, with enough data, we can build accurate models that zero shot it. The first time the robot figures out how to form the part accurately without having to do any kind of iteration.
I think this is like a very novel way of forming a part.
Yeah.
Can you talk about how the process actually works from just taking a flat piece of sheet metal to actually having a form part?
So forming is our core operation, right? Actually, the robots do more than forming. They do trimming, they do bending, hemming. Those are some of the things we're working on. Heat treatment.
Did you just start with
hole
forming?
Making. Well, forming was a core operation, right? But the goal is that the system can do, anything a human craftsman can do. Because once you have that, then you set up a facility, you have 20, 30, 100 of these, and now you can program that facility to do all kinds of operations, to make all kinds of different parts. But we thought really hard about, okay, this is a platform that eventually can do any parts, but where do we want to start with? Forming is one of the, I think, is the largest metal processing sector. Most of the metal parts you see around you are formed sheet metal parts. And the traditional way of making formed parts is that you have to make a die. Giant stamping presses. These are sometimes 4-story building size stamping presses. You put 2 matching dies. You put a sheet in between them. You apply pressure with the stamping press, and you get your part. So, and the bottleneck over there is just those dies. I was talking with some of my friends in Tesla a while back. A full set of dies for one of the first cars they made was $120 million, right? So you're spending significant amount of dollars to get your first batch of die sets, to get your first batch of parts. So with our process, we realized, okay, we can get these robot sheet formers to form sheet metal without the need for die. And the way they work is similar how to a potter forms a clay bowl. 2 robots, they have 2 stylus finger-looking things that are super accurate, very highly rigid, can apply a lot of force. They come and start from a flat sheet that's kind of fixtured in between them. The 2 robots come from 2 sides, start pinching the sheet and expanding the sheet as they pinch it. The same way, you get a little, Play-Doh and you push it from 2 sides, it expands. And then as you expand, one of the robots starts giving it shape. So it deforms it, expands it, and gives it shape. And then incrementally over time, you get to a shape that is defined through software, just instructions sent to a robot, and there's no static die that is required. So complete gets rid of the die. A matter of hours after your design is done, you can start getting the first physical part.
For something like this, when you are doing scaled production of a single car, let's say the Model S, it makes total sense to invest in that die and buy the 4-story building thing. But for most iterative working on things and just iterating on a design or process, that does not make sense to make a die for. So what kind of initial products did you guys work on?
So the natural fit is where the design constantly changing, right? Everybody thinks of our application, maybe it's a good prototyping, kind of tool. Prototyping is great, but I think, we always thought that this could be even go to early production volumes. So we look at applications where, they're making a few thousand of each design a year, not a million like you would do Model Y or some, Ford F-150. Few thousand a year, but then you want to constantly change your designs after, you manufacture a few thousand. So aerospace became a very good fit. The number of airplanes that total being manufactured is a few thousand a year. At best. Rockets, defense systems. So those became early customers. So Department of War became one of our early customers to repair their current
They're like
weapon
fleet.
systems, their fleet,
Yeah.
right? An aircraft gets damaged in mission. How fast can we make a replacement part for a skin of an aircraft, a landing gear door for an aircraft? Instead of waiting 4 years, making dies, can we get it in a matter of hours? So that was the first application. Expanded to more defense applications, missiles, hypersonics. Those are one of our biggest applications today. But then on the commercial world, there's a whole bunch of applications as well. We have Franz Solo here, so we had a lot of art, entertainment, architecture applications. But my favorite application is actually, I'm a car guy, so I used to make cars panels with hand. So I always wanted to use these machines to make custom cars, to make expressive cars. We announced recently a collaborative work that we're doing with Toyota, enabling people to design a car that's uniquely expressive of what they want and how they want it to look like. Being even able to go into a website and say, hey, I want a Toyota Tacoma, but I don't want it to look like everybody else's cars. I want the door to look like this. I want my favorite sports team to be formed on the back of the tailgate, and I want this unique vehicle. And I think that's another very interesting application we recently started working on, and I'm excited for it.
How did you kind of come up with this idea in particular? Because my understanding is that no one is really doing something similar to this.
Yeah. So, I come from aerospace background, right? I actually have like a unique kind of thick mix of aerospace and software. Academically, I was on the software and AI side, but I ended up going, more than a decade ago to SpaceX. And that's where I started getting more familiar with the manufacturing. And kind of very early on, I kind of realized that like the biggest bottleneck for hardware world is not that we don't have ideas. It's not that people don't want to make all kinds of great products. Is that every time you have to build something, you have to build a factory for it. So once I was at SpaceX, I really saw this tangibly, that, every factory is custom built for the product you're trying to make. You look at SpaceX's history, now they're a 20-something-year-old company. It was founded in 2001, 2002. There's 2 rocket families that has been manufactured. One of them is like halfway there, Starship, right? And both of them are built in 2 different facilities, 2 different sets of tooling, because you have to build a factory every time to try to make a product. So the seed of my career kind of started at SpaceX. It's like, hey, can we build factories that can make car parts in the morning and then rockets in the afternoon, right? And they're not custom and specific. So I got a lot of excitement about 3D printing. So after SpaceX, I spent some time at Relativity focused on 3D printing. But 3D printing was amazing, but it could only enable certain type of parts in an agile way. And then, I started Machina in 2019, really focused on, okay, what is the underlying platform we can make that can do all kinds of manufacturing processes? And to give credit to the people who have been working on this, I mean, people have been thinking about this for decades, right? There are people who have been thinking about using robots in an incremental way to do different types of manufacturing operations in universities since 70. Some of those folks, I'll give credit to like Jian Chao, Professor Jian Chao at Northwestern, they've been thinking about these since 90s and writing papers around them. The key was, how can you do it accurately? How can you do it cheaply? Right?
Like consistently.
Consistently cheap in a cost-effective way and accurately. And I think the missing pieces was like cost-effective robotics, but then artificial intelligence to come up with the right set of process parameters as a human mind would do. And I think those were the pieces that didn't exist till today. But we're certainly standing on the shoulders of a lot of researchers and folks that have been working on this for a long time.
Working at SpaceX and kind of seeing Elon work firsthand, what do you think is the limiting factor to basically making more Elons?
I think, it's a good question. And I think it's a billion-dollar question, right? If society could make billion Elons, I mean, like we're gonna be in a completely different world. From my perspective, there's 2 components. One is Elon is extremely multidisciplinary, right? I think if you have a common knowledge in one discipline, could be extremely useful and revolutionary in another discipline. You have some idea in automotive that everybody knows about it, it's commonplace, and you go to aerospace and be like, oh my God, why haven't we think of that? So thought of that. Same thing with software. I think he started in the software world and he captured all these ideas around agile manufacturing, rapid iteration, rapid testing. And then he brought in the hardware world, which was very risk averse world, right? Like waterfall planning for years. Nobody wants to take risks, and he kind of combined those things. I remember there were days, in one of the last few months that I was at SpaceX, they wanted to test a Rapture engine, which is the engine that became the Starship's engine. And people were like, yeah, this engine is not ready for testing. We're not going to do it. And I was like, just do it. It's going to be my birthday. Worst case, it's going to blow up. Fireworks, right? So he also, brought this idea from software world, like rapid iteration, do it really fast. I think that helped a lot. And then I think it was just significant amount of courage that probably got reinforced through successes in the past, where like he was just like positive optimist. He was like, okay, you know what? We're going to do this and it's going to be fine. It's going to cost millions of dollars, but it's going to be fine. We're going to figure it out. So there's like that courage of like trying new things and not be scared. I think those two, like multidisciplinary and significant amount of courage to try things, it just became significantly useful in the areas he went into.
I think some of the ex-co-founders of PayPal, when he was first starting SpaceX, they like made a video, a compilation of all the rockets exploding, to like try to deter him from basically incinerating his 100 million that he had just made.
It was like, that's fantastic.
Yeah. And he just kind of decided to do it anyway.
Yeah.
We were, talking earlier, and you said before you basically made your first prototype, it cost like a total of roughly $300,000. And you basically got the parts required to build your first prototype with just through very unique ways.
Yeah.
And I'd definitely like to kind of go over what are those, how do you do that?
Yeah. I think that's one thing I learned from SpaceX is that make things working as soon as possible. Like don't get stuck in analysis paralysis, get something out there, try it and see how it works. So when we started the company, we had relatively small seed round at the time. I think we raised like $2.3 million. So we certainly didn't have a lot of money to do a lot of experimentation. And a lot of like kind of thinking through things before we get started. So we were like, okay, we need to, in a matter of a month, get some parts forming. And we went to some of our vendors that we use today, and everybody has like 6 to 1 year lead times before they can even sell us any new equipment. So we're like, okay, this is not going to work out. So trying
to move at startup speeds. This doesn't work.
Exactly. So I was like, okay, you know what? I'm going to go to Detroit and try to see if we can buy some used equipment, used robots, used sensors. And I was like, okay, Detroit has all these auto companies. They use a lot of robots, scanning sensors. And I remember I went to this, it's like, I would say like, kind of cemetery of robots. It was like this giant robot and the outskirts of Detroit, giant warehouse in the outskirts of Detroit. And it was actually pretty eerie. You enter and it's this like giant room of dead robots.
And just failure, just sitting there.
And this guy is buying these from, from OEMs, automotive OEMs, to just scrap them, right? And sell them for parts. So we went through that warehouse and found like a couple that was working.
Mm-hmm.
And I think we bought those at the 10th of the price of a new set of robots, and it was immediately available. Just put them on the back of a flatbed, send it to California.
What would normally cost like millions of dollars cost like a couple $100,000.
I think so. I mean, like, we bought the robots itself at the time where, new was like maybe $200K each. And then we bought them for like $20K. So like 10th of that price. And, I ended up also at the time, I wanted to be very cost effective. So we had a very good landlord that was very into robots, and he was constantly bringing his friends to show the facility that we were working in. And I'm like, hey, what would be cool to have in your facility is a couple of robots. And he was like, yeah, that would be great. I was like, yeah, if you want to chip in, for half of the price of the robots, I can kind of like give you more equity. And I was paying rent with equity at the time.
And how did you negotiate that deal?
We just had a good landlord. I think he was, he and his family, they had a defense company as well. They had a defense industrial company, and he was really excited about what we were doing.
So they kind of had some history of like understanding that this stuff, typically in the early days of like, especially a hardware company, you need space,
yes.
But you're tight on cash.
Yeah, and they were a huge supporter. I was like, oh, this is cool. I want to be part of this. This is next generation of manufacturing. So they were early believers, and I think, so they bought in, they were like, okay, the first year you can pay with equity. buy some of your equipment with equity. But then, the catch was like, I want to be able to bring some of the friends and people that I know to see this. I'm like, that's totally fine. It works out. Yeah, so we were pretty scrappy. In a matter of 3-4 months, I think we put together for her system together and formed part for our first customer, which at the time was Air Force and NASA.
How'd you end up getting that first customer?
Yeah, so I think, well, one of the benefits of our team was that we came from aerospace.
Mhm.
So, and I spent 1 year after relativity space talking with a lot of people in the industry. So by the time I started the company, we already knew who the customers were. They were like, hey, there's no doubt we need complex formed sheet metal assemblies.
Someone's hair is on fire and you can see it and they
Yeah.
know it. It's just, it costs so fucking much and the lead times are ridiculous.
Exactly.
Yeah.
And they're like, if you can do it, if you can make it with robots, you can do it faster, we'll buy it. And so we had the customers even before we started the company, but so it was our own initial network. So we didn't have a huge challenge with the customers early on. It was mostly about just like, can you actually deliver a product, which was a big if at the time.
When you kind of set out, that you have customers and you're going to start this thing, you've got the space and you've got, your first or like essence of a plan. How did you kind of think through going from nothing in an empty warehouse to actually manufacturing parts for customers?
It's kind of, well, now I'm thinking about it, honestly, it was just like one step at a time, It's like, okay, we need to buy robots. Okay, we need to buy robots. We need to put together and weld things together and put stuff in the ground. It was like, 1,000 steps and start taking the first step and then do it as fast as you can. I think I was lucky that I was able to kind of work with some of the folks that I knew from previous companies at Relativity and SpaceX, kind of joined me early on. My interns at Relativity joined me, and, we were all too naive to know that this is not going to work. We're like, okay, let's just, or it works or not going to work. And we just took the first step and then the second and the third, and just did, do it as fast as you can. So it wasn't really, it was just general as like, do it as fast as you can, get to the forming part, and then just figure stuff out as it comes up. Beyond that, really, it was just tenacity and just figuring problem solving, right?
Were there any big like hurdles before, you were able to ship, like going into, it's nice to say in like hindsight, you took 25 different attempts to make the first part, but I imagine that at the time, that kind of sucks. You make the first version and you're like, holy shit, everything broke.
Yeah.
Make the second, 10th, even 15th, and you're like, fuck, it's still not there.
Yeah, no, it's kind of funny. You mentioned that, but we were just having fun. I remember the first part we made, we gave some instructions to a robot, formed a part, and we were like excited that roughly the shape is there. We're like, oh my God, we never thought this is going to work. But it kind of looks like the ghost of the part we wanted to make. And that's good enough for us to get all excited. So I think we were just excited to get any result. I remember in early days, we didn't even have a full-on software to control the robot based on the sensor inputs. So we will actually take turns. I would literally sit, or some of the other team members will sit at the robot. And sometimes these builds are multiple hours, right? And we will look at the sensor data and play like we are the controller. We would actually make adjustments to the location of the robots and to make it
manually, just vibe roboting
manually. And it was just exciting to go and see how these parts come out. We're not even thinking about, oh, it's failure. It's like, okay, I wouldn't do it. I wouldn't want to do anything else. This sounds fun. We have giant robots that are forming complex shapes out of sheet, and we're here to play with it. To some extent, it was just naiveté of like not caring about the end results and just pushing through and do the cool thing with the robot until it works, right? And then we will work as much as we could, and then we'll get tired and we'll go to sleep and then come back the next day and just keep doing it, right? We just felt kind of lucky that we have the resources and the time to do this. And we don't have to worry about a lot of other things, right?
Did you have a similar experience at SpaceX? Because I think you were working there, like, wasn't it 2012-ish time frame? That was like before they actually landed the first rocket, right? Yeah. What kind of experience did you take from that to this company?
Yeah, I remember, one thing was probably very formative for me at SpaceX was we had to do way more things that we had the expertise for in those days.
What's an example of that?
Like, for example, we might have to do a physics-based simulation of a certain thing, certain, manufacturing phenomenon. And we don't have the PhD in physics simulation that can do it. And the idea was like, well, who's going to learn it? And who's going to make a first attempt? And that was a pretty complicated concept for me to wrap my head around. Because, I came from grad school before that. I left my grad school to go to the industry. And, my previous thinking was like, you need to go become expert in one field. And that's what you would know. And you go try on other experts to figure out their things. And to some extent, that's true. I mean, there's a value in becoming an expert in a field. But when you're working in such a multidisciplinary field, the coordination between the experts is also a whole other set of challenges where a lot of time it makes sense for the first early iterations for people to gain more breadth.
Yeah.
Right. And I think that was the unlock for me at SpaceX is like, hey, anybody can go much outside of their field and learn a lot of other skill sets and start putting the early version of things together. At some point, you need experts to come in, but you cannot start with all the experts present in the room. Right. And that was actually like not something I learned in school, not something that was taught to me when I was like a kid. It was like, I thought like, yeah, you go through school, you become expert in one thing, and that's going to be your contribution. But SpaceX kind of broke that for me. I was like, no. Like you can go learn those other things. Right?
Yeah, there's definitely an advantage in kind of on purpose, keeping the team small and giving like latitude to people to just go own an entire part or process and figure it out. Because then, it's not like playing telephone with 3 different parties.
Yes.
It's just one person focused on that thing 24/7.
Yeah. And then you're just thinking about, I think, again, there's a huge value in being an expert. But when you're setting something early on up, who is an expert? Somebody who spent 4 years maybe of their PhD figuring something out. Okay, if I can fast track that, can I learn that in 2 years if I'm really excited about it? I think that was the mentality I developed a little bit at SpaceX. And I think it's hugely important for these like multidisciplinary startups where you need to know enough to get things going. At some point, you need the experts and they need to come into play. But, getting over that fear of, right, like you could learn these other very advanced fields enough to get started.
I imagine if you're creating something from scratch, you want people that are just like self-starters and they're figuring things out. Did you look for kind of track record of having built things in the past, or what were you looking for?
Yeah, I think, bias for action is huge. You're to a point, like people who have done things in the past or not scared of trying things and building the whole stack. To some extent also, I remember in early days, I would go talk to experts in robotics and they would be like, this is not possible. You're applying a lot of force with these robots. They're going to deflect. They're not going to be accurate. Robots are known not to be accurate. This is not going to work. And so I started trying to kind of get a little bit disappointed. Okay, these experts maybe are not the good fit to start with. So I think early days, I went back to my interns even, like in previous companies. I was like, hey, you guys are about to graduate from school. Do something. And these guys are smart, high bias for action. But almost all of us were a little bit naive and, to criticize it too much. We're like, okay, this would be cool. Let's try it and figure out what's going on. And then that early team came in and then they tried it. They didn't know what the outcome is going to be. And it kind of worked. And then afterwards, like, some of the experts looked at it and was like, oh, I guess it could work.
Yeah.
And now we can, now we can develop it further. But yeah, I think those early days, you want really bias for action. You want really smart people that have a lot of bias for action. And again, to some extent, naive enough to try things and not immediately dismiss as, oh, it's not possible.
Did you have to screen out anyone that kind of had, a huge amount of expertise and looked good on paper, but just it wouldn't make sense in a real world scenario?
Oh, yeah. I mean, we sometimes screened them and sometimes didn't screen them, and they came and, and then later on realized maybe it's not a good fit for them. Mm-hmm. Right. It's a double-edged sword. You know a lot about certain topic. Obviously you can do a lot, but also like it just kind of cripples you. It puts you in the analysis paralysis mode, right? Where you constantly double, checking yourself, putting doubts. So we certainly had to screen for it. And sometimes, we hired some folks that ended up realizing, okay, maybe this person was, smartest guy ever, but maybe not the best fit for where we are as a company.
I really love Travis Kalanick, and he had this thing where whenever Uber entered a new city, he would try to like celebrate the city in some way. And I think a lot of what you guys have done is kind of similar to that, where you find some customer and you kind of celebrate the customer. Even with Franz, he's this like amazing designer and has designed cars that millions of people use every single day. And you kind of celebrated him by creating this.
Yeah.
What type of philosophy are you taking to that when you're just making something like a Toyota truck or, a Franz statue?
Yeah. No, you're absolutely right. I think, our long-term goal is you have a system that can do all kinds of metal structures autonomously, right? And that's a huge market. It's $1 trillion market. But almost that can become the impediment to actually like grow fast, because now you have so many markets that you can go after.
Yep.
Right? It's just too many applications. Like, okay, am I going to work in heavy machinery, in agricultural machinery, in automotive, in aerospace, in defense, in architecture, in entertainment? Like, everywhere needs metal. So to some extent, we were like, okay, we need to make few applications very happy. And what we chose in those few applications were things that we were also excited about ourselves. I loved custom cars. I used to make custom cars. So I was like, okay, this is an application we're going to go. I know enough where I can have a very good, intimate conversation with our customers. One of the things we did with Toyota, I remember early on in the conversations, the Toyota manager that we worked with, we went into a meeting with other Toyota execs, and he was like, Ed is one of us. He knows cars, and he's like putting his money where his mouth is. And he just wants to love to build cars. And he already built a car for, themselves without any customer. They already have a car that's amazing. It's fantastic, right? So, and the same thing when we came from aerospace, we were in that industry. We were excited about the application. We could become thought partners. We're not just a supplier, right? We're not like, you call us and then we'll build whatever you want to build. I'm going to give you opinions. I'm going to be like, hey, this is how you should build it. This is how it's going to get better. I've been thinking about it over the weekend, and here's my ideas and my thoughts. And then the customer is like, okay, you're not just a supplier. You're excited about what I'm doing, and you want to be a thought partner into it. And that was a key principle for us to choosing applications we're going into, to have a significant amount of knowledge and interest in that application. And then slowly, and each of those applications could become hundreds of $1 million in revenue for us, right? So they're not small applications. But instead of going broad and just selling to everybody and being kind of this dumb, uninterested customer that just want to sell you a machine or sell you a product, we really wanted to partner. Yeah.
Did you do anything that was just purely for your own curiosity and excitement, like making any part that wasn't for a customer, but just because you wanted it to exist and wanted to see if the machine could actually make it happen?
I think if I ask me, I will always be like, no, there's always that rationale behind everything we did. You ask our team, they're probably going to be a lot of times like, Ed was like, why are we making this? And it's probably what he wanted to do. I think, building the truck was one of that, right? And then later on end up becoming, help us close deals. But I think that's part of the situation, right? Part of the, if you're not excited about it, then you can't sell it either, right? If I just purely making decisions based on logic, then I'm out there and nobody connects with that, So
I think a big part of this is you have to create a story that other people want to believe in.
Yeah.
And the best stories are something that they haven't heard before, and you kind of come up with it in your own head, and you just show it in the real world, and then they're surprised by it, and it resets their own expectations of what's possible.
Yeah, we made it exactly. We made this showpiece. It's a SR-71. To me, it's the best plane ever made. And it's very complex shape, It's one of it is at the time the fastest plane made. And, we purely did it because we were just a fan of that plane. And the moment we made it, it was just mock we wanted to take to a show. Half of my customers, a lot of them would start calling me. I was like, hey, can I get a version of that and have it in my facility? Because you do something authentic. I think people just connect with it and be like, okay, these guys are not here to just make money. These are not here to just make machines. They're excited about this industry, right? And we are.
I know there's different kind of schools of thought where some founders want to basically build a company in order to integrate with some other business and then sell that. I think most of the best founders are basically just trying to build something that will just keep on evolving over time
Yeah.
and grow into a massive company. How do you think about that when
Yeah.
you were first deciding to start it?
I don't think I ever joined any company where my end goal was to sell it. At Relativity Space, I drove part of the founding team. That was not the end goal. Same thing with Machina. I honestly, we didn't even start this company to be like, oh, let's make a profitable business. It's just,
I kind of love that.
It wasn't really that, right? I mean, I had this kind of remote trust that like, if you build something that's cool and useful, you will make money, right? While we started, what I wanted to do was like, I was really interested in building physical things. And I was like, as a college graduated, in order for me to build physical things, I have to join giant companies, SpaceX's of the world, Honda's of the world, Toyota's of the world. And they're great companies, but I need to be part of this larger whole that has enough resources, can build factories, can turn my ideas into reality. So really at the core of this was like, can we enable expression for people with great ideas? Starting with ourselves, with the people who started the company. If I want to build a Franz Solo, how easy can I make it? Yep. Right. And I think that was
something that you can do at your own company, but you can't necessarily just go inside of a big company and say, I want to make this cool thing. Yes. And I want to use one of our machines to do it.
Yes. And I think, and even if you want to do it in those large companies, that means huge investment in tooling and, a lot of custom specific machinery and equipment that you have to build to make it possible. And just economically not feasible to just do whatever you need to do. So I think, or you want to do. So I think the core really inspiration was, and it still is for this company, is like, I would love to live in a world where any great idea can become real. I walk around, you walk around in the streets, all cars look the same. All buildings roughly look the same. There's not really design diversity in our physical world. So really the core thought was, if we make a company that enables a freedom of expression in physical world, that's going to be a massive company. That's a company that's, that's going to define the future. If tomorrow, any sci-fi movie that I watch, there's bajillion cars and hovercrafts and rockets and satellites and bajillion designs of buildings on multiple planets. I'm like, okay, the factories we have today are not going to make that happen, right? So we need something that's flexible and can do all of these things. So that was really the initial motivation. And, and we loved building things. And then our customers are great. They come in and I was like, yeah, we're on the same page. Let's make this happen. And then the rest becomes, what is your path? In technical terms, we call it go to market. Okay, who's your initial customer, and then your second customer and your third customer that sees this benefit until you build that world. So our long-term goal is, I think, Machina could be a very large company, a company where, you have some ideas, you go on a portal, you start turning your intention into a design by even speaking to it, or working with it through neural lace, transferring your intent into a design and be like, hey, I want 300 of that in Hawthorne, California, in Los Angeles, California. And then the right facility gets programmed to make that part and ship it to you, right? And anybody in the world can do that. I think that's a $1 trillion company.
John Collison has this line, I think he tweeted it a while back, where he said, if you just look around in the world around you, everything is so extraordinarily difficult to actually make reality. Even like a bench, like a park bench, is so complex to get, deal with all the regulation, all these hurdles, that is effectively just like a universe. You look around and it's just a universe of passion projects. Yeah. And I think it's very, very positive for any company if they basically lower the barrier to enabling people to make those passion projects.
Yeah. I think, if you think about, humans, I always think about what does it mean to be human, especially now it's becoming, kind of like a more pertinent question with AI and everything else. I think for me, being a human is, we're here to express ourselves in each of us in our unique ways. You're expressing yourself with this amazing podcast that you're making. and that's how you want to define the world, and that's your contribution to the world, that's your expression.
That's my leverage point.
Yeah, exactly. And I think, if we can make expression for people easier and easier, it's very easy to put your thoughts now in words, in computer screens, in apps, but physical world, still very hard to be expressive in it. It's very hard to have a car that uniquely expresses you. It's very hard to have a home that uniquely expresses you. It's very expensive, very time consuming to do that. So I think that's a frontier for me. I mean, like if you think about philosophical frontier, is expansion of the boundary of expression. And I think that's what I'm hoping we're doing here at Machina.
When you first start a company, there's a million constraints. Like you said, you raised a little bit of money, like $2 million, and that might be enough money to start, but it's not necessarily enough money to scale to massive facilities that cost hundreds of millions of dollars and deploying huge amounts of robots. So how have you kind of thought about at any given point in time, what are my constraints? And then what can I do like with maximum leverage on the resources that I have available in order to get to the next stage where you have less constraints or different constraints?
Yeah, it's like, almost it's like a running list of what is the highest risk to the company. You might have 200 risks to the company. And when we say risk to the company's revenue and survival, right? Like how long you can do this and how reliably you can do this. What are the risks to that? What are the dangers to that? And then you kind of create a list. And then your job, I think, as a CEO or founder is like rank that list from the most imminent danger to the least imminent danger, and then go after that list. Like, okay, how can I resolve number one? And like, you literally have to be like almost dogmatic about it, not care about anything until number one is resolved, or usually like number 1 to 3, because like, there's some fluidity between which one is number one.
You stack rank the list of fires and you say that one will burn down the building.
Yes, exactly. And actually I have like, it's on my phone.
Go for it.
Like, if you look at like, it's like they have there's like 3-4 things on the background of my phone that are just the highest risks for the company at each time.
What are those right now?
Number one is we need to learn a new forming policy in sim using AI. I want to make sure if we finally be able to fully, just in simulation, learn a policy to form a sheet of metal. That's like number one risk for the company that I put on there. Number 2 is actually talent, right? Like, there's a lot of stuff around hiring the right people. And then number 3 is our largest customer that's coming up. That deal needs to close. So those are my top 3 today. And I think that's just what it comes down to, right? And be very realistic about, what are the solutions to those top 3, and constantly iterate until they're resolved.
I kind of love that, because people like spend a huge amount of time on their phones, and it's really useful to know exactly what the biggest problem is at any given time, and be like, basically have a constant reminder of this is the thing I need to be focused on. When you open your phone and you're like going to check Twitter or LinkedIn, the first thing that you see is, holy shit, this customer needs to fucking close or else we're dead.
Exactly. And I think it's kind of funny because, in a startup, you're constantly being pulled in multiple directions, especially like, as a CEO or as a founder, or even executives, or even like, high performing engineer in a startup. There are a million things you need to work on, and people are going to tap on your shoulder right and left and be like, can I do this? And every once in a while, I have this, I look at it and be like, okay, I can just not respond to that right now. I don't need to respond to that. I shouldn't. If I'm responding to that, I'm wasting time, and it's not fair. Like, I'm actually not doing the right thing for the people in the company, even though they want me to respond to that, I need to let it go. But yeah, I think that constant reminder, you also have to brutally get rid of noise, right? And focus on the top 3 most important things.
So going from you build the first version of the machine and you start making parts with it. How did you kind of go from deciding to just use that first machine versus like making a V2 and starting to scale up and make new iterations on that? Like, what was that process like?
Yeah, I think it's a combination of, some of the stuff that just doesn't work.
Yeah.
Right. You look at it and be like, okay, this did not work, so we need to change that. And the vision that you have for the machine long term, right? So like you're making compromises between the two. For example, again, it goes back to that list of risks. So it'd be like with the first machine you built, you de-risk the most important things.
Yeah, just straight up, will we even build the first thing?
Can I even form a part with it, right? And if you
Was that a question mark in the back of your mind when you first started?
the first one, yeah. I mean,
Amazing.
it's like, can we put this together and form a part that kind of, does it even look like a design of a part that we want to form? So that was the first. And if you go to we went to the other building, that was the first cells, right? And then once you remove those risks, then becomes risk number 2, number 3, number 4, and start, kind of going through that. So, our first iterations was all about feasibility. Then I think at our second iteration, we started thinking about, okay, if the system works and you can actually form parts and make metal parts in a fast way, the next biggest risk is how fast can we set up factories that can do these things? So
deploy the system at scale.
Second iteration was like, it needs to be deployable, right? So we went from grounded, connected to the concrete, rooted in concrete systems to, build out of a container platform that can easily be deployed, because that was the second risk. You can make parts fast, but if the factories take forever to build, then that's the biggest risk. So let's make a system that's portable.
You've basically got the system now that it can basically fold up and fit on the back of a semi-truck. Did you kind of come in with that idea and say, if we're able to put it on the back of a semi-truck from day one, like it will make it very easy to move around? Or did you come up with that later on?
Yeah, no. So I think we always knew that the system needs to be easily set up.
Yeah.
But what was that form factor? Was it like, oh, you can put it in the back of a truck? Is it a container? Is it modular system that can be easily kind of connected together? I think that was not fully fleshed out.
What were your other initial ideas of what that looks like?
I think the other idea was basically the stuff that I said. I think, we did one iteration that was not a container. You could just put it on a flatbed. And then we saw some challenges with it. And it was we dropped that design. The other iteration was can we make a modular design that can easily be assembled? You put it in ship sets, but then it's kind of like IKEA. You go to the other side, and in a matter of a day, you can put it together. And then we realized the system is so complex that's not even possible. So we landed on this container idea, and to some extent, it's, philosophically, that was always in the back of our mind, is that any technology that stays with us got to move with us, right? We are nomad species, right? We have been constantly on the move. Even on Earth, we've been on the move, and now we're going to other planets. So any technology that's too static is never going to be able to survive long term. And container was this unit of mobility. So it kind of made sense afterwards. It's like, oh, it just got to be
in hindsight, container. It made sense, but obviously you can't just at the time, looking forward.
We're trying a whole bunch of different things.
Going from the first prototypes and starting to make parts, were there any directions that you went down where you later realized that just makes no fucking sense and we got to kind of go backwards and retry?
It's kind of funny. I think it's hard for me to fully pinpoint that, because I feel like, we made a lot of mistakes, but I think we tried to immediately fix them. Like these in designer things, to begin with. For example, when we first started to build our software stack, we were hell-bent on, okay, this needs to be really automatable, almost like an API kind of software where it's all command line. It doesn't require to have any kind of an interface. You just feed in geometry into it and the robots get going. And then we soon realized that's oh no, everybody in this space needs to have visual feedback, right? And we built our first iteration of software to be fully command line based. And then we soon realized, okay, this doesn't scale other than, a few of us who are nerds about command line, it's just not gonna easily scale beyond us. So with the next version, we went more toward a visual paradigm. So same thing happened in our business development, right? We first, I remember in 2023, now we're talking about 3 applications that we were focused on, but 2023, we worked with 30 different brands. And out of that work, and each contract was 50, 100K value. So very small values, but we just didn't know who would be the right customer to begin with. So we tried a whole bunch of things, and a lot of it just painful. And we wanted to deliver on those contracts, painful industries that were not a good fit for our application. You could make middle structures for them, but we're not touching the real enough pain point that was like, okay, this is an industry that we can grow into. And the key was like, do it, deliver it, make true on your promises, but then, make an adjustment immediately. So there's a lot of those painful moments. But I think I would like to think of them as learning moments, right? Less so as like, kind of full on failures.
Yeah. Jim Belosic from SyncAscend, which we interviewed, we both know him.
Jim.
He didn't read a bunch of business books. He hasn't watched a bunch of lectures or talks, but he kind of intuited the right way to run businesses, or at least for him, like his model of running a business. And he's got all these interesting things like when he recycles aluminum and sheet metal, he gets paid in cash by one of his, the person that picks it up.
Yeah.
And then he basically like lubricates his business by whenever someone, a FedEx driver shows up a little bit earlier, stays a little bit late, or someone on his, in his factory is working a little extra hard and he notices it, he just gives them $100.
Yeah.
And there's these interesting little ways to make the business run better and make people happier day to day. Do you have anything interesting like that?
It's hard to beat Jim in this kind of ideas. I think, food is pretty important.
Food.
Food. Yeah. Good food. I think, one of the very early things that I soon realized is that, people have intimate conversations usually around food, around dinner or lunch. And, one thing we started very early on and still kind of stayed on and at Machina is like, we started with like once a week early dinner that we kind of cater to the company.
And bring everyone together and...
Yeah, just everybody come in, just the pressure of the work is off. Let's sit down there on table, chat. A lot of good points come out of those conversations that are just people are casually bringing it up. And I, now we have like, lunches and we do happy hours often, but, people think of those kind of like little perks as like perks of work, but I think it's actually around, it's a huge productivity lift. Like, how getting people to just like, without the stress of work, just sit down and have conversations. Again, probably not as good as what Jim has. That's a pretty interesting way of like, okay, like let me sell my scrap metal and reward people. Not as good at, but I think, I realize, just lunch, dinner, conversations around food is always very authentic and helpful.
Going straight to Toyota might not even be the right model because you can't immediately just scale up to delivering 1 million, truck bodies a year. Like it just doesn't, you can't just snap your fingers and make that happen. So how did you kind of think through which customers at what stage of the company would make sense to have the highest leverage and learnings just internally? Yeah,
I think early on, it comes down to a pain point, right? Who has the biggest pain point? Because the earlier you are, the more risk you have.
Mm-hmm.
So the pain point of the customer needs to be so big that it's willing to take the risk, right? I think, even though, our company is not necessarily just a defense company. We're excited a lot of other applications, but defense and aerospace, they had a huge pain point because they have a high variety of design and huge cost to change things over. So they're looking for agile technology that can easily go from one design to another, one material to another. So they become a very good fit. The other piece was, and then, later on we went into auto. Auto became a secondary application for us. The other piece really is about, manufacturing is so tightly coupled with everything our customers do. I mean, think of Toyota, think of an aerospace prime. They are a hardware making company. So manufacturing is just at the core of it. We're not like another supplier, like for example, Microsoft, who sells them like this tool, productivity tool. We are the core of what they do. So any changes in that core, they take it pretty seriously, right? And almost nobody in the company is willing to take a risk to make a fundamental change in the business just by themselves. So what I soon realized was, in order for our customer applications to become successful, we need to get a lot of champions involved. The technical guy might come in and be like, yeah, you guys are a good fit for our application.
But you got to
But
have someone internal at those other companies that want you to be a
you
part of
need to
their
have
business and want them to win.
10 guys.
10.
Yes, in those companies, because it's such a fundamental change. So you get the technical guy in and say, okay, yeah, I like it. That become one champion. You need to get the business guy to come in and be like, oh yeah, this business wise makes sense too. So I'm willing to bet my career on this. And then you need to get the investment team at the company coming in and be like, yeah, we would love to actually, we see the value enough that you actually want to invest in it and get some of the financial benefit as this company grows. You want the CEO and the executive team to come in and be like, yeah, this is something I want to talk about in media, but and actually advertise
This is
our
cool. We
engagement
want this
with
associated with our brand.
Yes.
Yeah.
And like I said, it's such a fundamental change that like you don't need just one champion like you would do with a lot of other products. You need to get 5, 6, sometimes 10 different champions across the organization to kind of make the change happen. And so that's one of the learnings we had early on. It's like you're not selling to one person; you're selling to the whole organization.
Yeah. Do you have a kind of a systematic approach? I imagine you don't have this day one, but through this like iterative process where you're talking with lots of companies, what's been the approach that you've kind of adopted over time to make this work? If you have 10 champions before something works, how do you get those 10 champions?
Yeah. I don't think it's yet a science. So it's
More
a lot of
art.
Yeah, a little bit of art.
You're putting a brushstroke on, see what happens.
No, I think it requires, really just talking to the companies, almost like, full court press, almost a strategy, right? Reach out to investment team, use your connections to work with the executives. Make sure engineering teams are super happy and backing you. Make sure the business case is solid, help them even develop the business case. So it's really about having a strategy to just make movement on all 4 or 5 fronts at the same time with all the team members. You need to have like alignment across your technical team, your business development team, your investment team, your legal team to really push. And it requires a lot of also like external, like our board members, our investors to be involved and kind of make these connections happen, make these conversations happen. Have a good marketing strategy. Just make sure the voice is heard out there in the right way. So, I would say it's a kind of full court press kind of strategy, right? And in the sports term. If you look at most of our customers, they're investors in us. Toyota's an investor. Lockheed Martin is an investor. Yamaha is an investor. So most of our customers that come in and also invest in us. And that's what we found works in these fundamental changes in these organizations.
They need to have a stake in your success.
Yeah, a stake in your success.
Interesting.
And the beauty is that a single manufacturing is such a large industry that a single customer can make or break, right? A single customer can become hundreds of millions a year for you, right? If it's fully adopts your technology.
When you started to kind of build these partnerships and building those relationships inside of those companies, like you said, you basically screen for talent super early and figuring out which people are going to be a fit of the company. But it also makes sense on the investor side as well to figure out which companies not only are we going to create products for, but also are going to be like DNA aligned. Because every investor, or at least that sort of thing, is almost like a organ transplant. And if that sort of thing can go bad if DNA doesn't match. So how did you kind of figure out which partners made sense?
It's a good question. I mean, we don't always get it right.
Have you had to fire any customers? And if so, why?
Yeah. I mean, we went, like I said, in 2023, we worked with 30 brands. Now we work with less than 10, right? But much deeper partnerships. Almost you have to go out there and make an attempt, put your message out there, work with people, and then also be honest and be like both sides and be like, hey, this is not a good business case for you. This is not a good business case for me. I'm sorry. Let's move on. And and it's tough because you want to make everybody happy, but I guess the lazy answer to a question is got to try it and got to be honest about how it's going. Is it a good fit? And then cut it off if it doesn't work.
Our last interview was with Mehul from Matic, and he talked about basically when he announced in late 2023 that they were going to start shipping, robots 3 months in the future. A bunch of supply chain issues happened, and basically they got delayed massively. And then by the time they ended up actually shipping the first units, what they did was they couldn't deliver the product that they thought they could. And so what they did was they just sent emails to everyone and said, this is what our product can do, and this is what it can't do. And if you want this set of solutions, then we'll ship it to you right now. And if you don't, wait 3 months and we'll deliver something that actually works for you. Did you do anything like that with customers on figuring out and setting expectations?
Absolutely. I think, a lot of these things for us, I wish we could be as preemptive about it, like you described. A lot of cases was like, we went in, we delivered, and then discussion on the next steps. Okay, can we do this? And we're like, okay, maybe we can do that in 2 years, but not today, right? And that kind of start filtering out a lot of customers. Again, I think it needs to be, you almost want, customers to be having enough pain point that they don't want you to walk away, right? And those are the customers you want to keep, right?
Mm-hmm.
So, we have to do that, but a lot of times the conversations like, it's phase 2 or phase 3 or phase 4 of the engagement. Yeah.
So you're going to be scaling up massively. Right now we're in factory 2. Factory 1, how long did you use just factory 1?
So we moved into factory 1 in 2020. And I think we fully deployed, we have, 11 manufacturing systems. 2 of them we kind of like brought down, but 11 manufacturing systems we had by the end of 2023. So with that full capacity. In 2024, we came into the second facility. I think we're going to be fully operational in this facility by 2027. So like looking at
everything's rung out.
3-year cycles for the facility to start and get to full capacity. And then we're going to our next facility this year.
How are you thinking about scaling up? Suddenly it goes from we're just tinkering on how this thing works in the first place, and now suddenly you're going to be shipping actual units to your next facility. I think starting almost immediately, and then you'll just scale up over the course of the next 12 or 24 months. How is the business going to evolve, and how are you figuring out how to scale?
For us, it became, like I said, we started with a lot of customers, narrowed down to few, and then we start seeing some of those few out. Even within that list, 2 or 3 are now getting to the point where it's like, okay, let's scale, let's start making production. Like I said, we're lucky enough, we're in an industry that a single customer can get you to a few, tens of $1 million in revenue a year. So we can make those decisions based on the customer commitment, right? If this aerospace prime comes in and says, hey, I want you to make that UAV, and now, a lot of that conversation is also like, gives you like 5-6 years ahead, kind of like this is what the volumes will look
where
like.
Things are going to be going, and you can kind of plan for it.
And then we can plan for it. But that also only happens by us keep narrowing and being more intimately involved with each of the customers. So it reduces the risk of expansion. But once we deploy the facilities with our initial customers, then that facility, that's the beauty of our business, is that same facility can eventually service multiple customers. Like, you can start making with this prime first and then switch to automotive application the next day. So we almost kind of seed our applications with the first application. It's the first our factories with the first application, but easily can switch to other applications down the road and kind of like, serve other customers.
Interesting. At what stage does it make sense? So you've gone from like 30 trials to 3 really strong customers. At what point does it make sense to kind of expand back outwards and go the other direction and start doing that again?
That's something we always talk about ourselves. Like, I would love to someday kind of be like what Jim is for some of the other metal structures that we do today, right? Like he does a lot of good, machining, bending. We do complex metal curvatures. I think at some point I would like to be in a place where anybody can log into our platform, put an order the same way they would do at Send Consent, and get their parts at any volume. So that's a long-term goal. I would say probably we are like 4 or 5 years away from it. We started from very dedicated customers that have very transparent needs. And I think at the late stage of the business would be where we go back wide, and now anybody can put any order on the portal, and then we can kind of fulfill it once we start having 3, 4, 5 facilities that are serving our anchor customers. And then we can kind of fill the gap with these smaller orders and smaller customers.
Yeah. Jim talked about a lot of the things that he does are like non-traditional. He constantly talks about like, I don't want to have a CFO because a CFO will tell me not to do things. But I think the way that he's built his company is he's created an environment where he's going to be really happy day to day, and he's just going to be happy waking up in the morning and going back to work and doing that for a very, very long time. How are you kind of thinking, like, from the start, there's different points in the business, and I think over time, if you do it right, you are having more fun every single day.
Yes.
Because you're basically eliminating all the distractions that aren't fun and figuring out which are the fires that, like, I most enjoy putting out. How are you designing that for your life?
I think it's an interesting approach Jim has. I think honestly, I'm already there. I think I love problem solving, and I think I'm excited enough about our mission that doesn't matter what problem it is. I'll figure it out, right? And I'll dive into it. So yeah, I don't think I'm necessarily doing things that I don't like today. Even fundraising. I mean, people would say I'm being prosperous, not necessarily being honest here, but I enjoy it. I think it's part of going out there, talking to people, getting feedback, understanding in what ways what I'm saying doesn't make sense. So I don't know, maybe I'm fooling myself, but I think I've gotten to a point where I think I can enjoy every piece of the work that I'm doing, or I've learned to enjoy the pieces of work that I'm doing. Because it's a funny transition. I'm an engineer by the background, and, used to make cars by hand, car panels by hand. And I was like, okay, I'm going to make robots that make car panels so I can do the engineering work. To some extent, sometimes I miss that. Mm-hmm. But I'm as excited to enable so that our engineers can do it, enable our engineers to be able to do that and kind of vicariously live through them and learn from them. And so, I think, not to give you a fake answer, but I do enjoy my day today, even right now. I think it's just every problem is an interesting problem.
Jeff Bezos has this idea of one-way doors and two-way doors. And I think the biggest example of that for him was when they were first deciding to do like super saver shipping with Amazon. And they were deciding whether or not they could basically do a monthly subscription or an annual subscription that allowed you to get free unlimited shipping. And the risk there was basically that if you give free shipping, then the heaviest customers, the people that use the product all the time, are going to immediately adopt it. And so at the beginning, it's going to cost an insane amount of money. And then as you kind of scale down the curve of normal customers, people are just going to use the product more, or, use the service more. But it's not going to cost as much as those early customers. Has there been any moments during the journey where there has been this like one-way door that you had to decide, like, do we go through? Do we not go through?
It's like Rule of Botha is at Sequoia has a good name for it. It's a kind of crucible moments.
Yep.
He calls it crucible moments. Yeah, we had few. I think, when we started the company, one of the main things we had to decide on was, are we going to sell systems? Are we going to sell parts? Or are we going to sell full-on assemblies of metal structures? And the easiest route was to just not make a decision and be like, hey, we're open to all three. Let's figure out what's going on. And that's basically to some extent what we did. Sold parts for a little bit. We sold systems for a little bit. And I think came the moment where we decided that was like, okay, we cannot be doing all three, right? And it's a pretty tough decision because, you have customers who are like, okay, if I stop selling cells, those customers are not going to buy cells from me anymore. And if I don't stop selling parts, those customers will not buy. If I start selling assemblies, so we had to start kind of thinking about, okay, one of the most important things is for us to be clear about what our business model is. And we need to make that decision. Otherwise, we're going to be spread too thin across too many ways of serving our customers. Because you sell cells, you need to have a support system. You need to have engineers out in the field supporting your customers. You sell parts, you need to make a lot of them before you can kind of make, a significant amount of dent in your revenue, right? So that was one of those moments, right? One of those moments was like deciding, okay, what is our business model? We landed on, we sell assemblies, right? We actually use our systems to manufacture complex products. We sell those products. We're actually an operations company as well as technology company that builds the robotic system. Now, for some of our customers in military, we might deploy and operate these cells in the edge. But for the most part, there was a day we were like, and it's a tough decision because we're selling like, $3.5 million cells. And we're like, oh, some of the customers want that. We're not going to do that anymore. We're not going to sell $3.5 million cells. And that's a big amount of revenue. It's scary for our board. scary for the customers, scary for our employees. It's like, okay, you're never going to sell through it. I was like, well, it
I
just
got to
doesn't make
imagine you
sense.
have to like figure out which incentives you want, and if you're just, it's kind of like if the aircraft manufacturer also had to operate the airliner,
Right.
then they probably wouldn't design it so that they make all the revenue on basically the plane fucking
Yep.
up and failing. It's the same thing
Yes.
with cars. I think for a long time the car model was basically the car would be sold at cost,
Yeah.
and then all the profit would be made up on the parts when it failed.
Yeah. Yep.
And so with this sort of thing, you through deciding to just sell the finished assembly,
Yeah.
you're saying we're just going to make really great machines that do something very, very well, and we're going to own the full stack of understanding is it doing it well, and like the iteration loop of we just need to output things that people use.
Yes.
Versus just selling the machine.
Yeah. And it was uniquely the right path in the United States because to some extent, we don't have an industrial base anymore.
Mm-hmm.
You don't talk to aerospace and defense primes. They're like, hey, there are these companies that I go buy my my assemblies from. They're 100-year-old companies. These guys, they don't have any margin to invest in new technology. They don't have any strategic capital to employ. So to some extent, they were asking us to step in and become new version of tier one advanced metal structure supplier. Because if you want to sell into that ecosystem, and we could have sold it, but long term, they're not in a place to buy advanced technology and invest in it. So it was almost like in short term, we can sell to these guys, but long term, like we got to fix this problem fundamentally. We got to actually create a new version of, tier one metal structure supplier. And specifically in the United States, that has been eroded. If maybe we were a company in China, we would have made a different decision. But in the United States, it just made sense for us to sell assemblies.
When you're doing a hardware company, a huge part of the business is basically the factory space and the machines that you're actually doing, and you have to make this huge capital investment. And at the start, you just have to upfront the cost because no one will give you the money. But then over time, you have revenue, and you can kind of share that revenue and raise debt off of that revenue. How are you kind of structuring so that you can scale most efficiently?
Yeah, I think, to your point, one main difference between a hardware company and a software company is that your capital needs going to require a different structure. In a software company, simple. You go to VCs, you get equity dollars, and that's it. And you build until you build a high margin product, debatably high margin product, and then maybe you can kind of you can become a very successful company, go public, and that's it. One thing you learn very fast with hardware companies is that you need a very complex capital structure. You need equity dollars for R&D investments and engineering, but then you need debt to, buy hardware, finance your equipment, finance your purchase orders.
Mm-hmm.
You need, government potentially grants early on to do some early development work that's, high in CapEx. You need to work with your customers sometimes because these customers have huge, balance sheets, and they're
if you're working with a Toyota, it really fundamentally changes.
Yes.
$1 million or $10 million to them is
exactly.
Nothing.
In some ways, they can finance certain things better than a private equity firm or a venture capital firm or even a bank can finance it. So you need to bring money from your customers. You need to work with foreign governments to do foreign expansion. So you almost get this crash course in 10 million ways to kind of finance your business, and all of them are relevant.
Yeah.
Versus in a software company or a service company, it's just not relevant at all.
When you first started the company, did you realize that you were going to have to spend a lot of or like a significant chunk of your time thinking about this stuff, or was that learning along the way?
No, I was definitely learning along the way. I think I was open to it. I was ready to it. But one of the things you said, I never thought I'm going to start. I'm just doing mostly fundraise. I enjoy it now, but at the time, if you would have asked me, engineered me 5 years ago, I'd be like, no, that doesn't sound fun.
The thing is now is you've actually got a product that you can show and customers, and so it's not necessarily the same slog as here's the technical risk, and we haven't even done it yet.
Yeah, no, absolutely. It's a much better position in terms of it's much more straightforward to finance it. But still, you need to build that chops, right? You need to build that chops around what are all the financial products you can use to build your business.
Yeah. What stories would I just never know to ask, but are really interesting?
I think, maybe, a lot of people talk about it, but I don't think people tangibly understand this unless there are people in the startups. Like companies at the end of the day is people. Company is the people, right? I mean, I truly believe this. People think about, oh, it's company the technology. Is it company the customers?
Elon literally has a line where he says, an organization is just the vector sum of all the, like each
Yeah,
human is a
yeah,
vector, and it's just they need to be all pointed in the same
exactly,
line.
exactly. And it's one of the most, us and humans are highly variable. Like you have a lot of interest in, things that we care about, and the way we do things. So I think one thing that's maybe underappreciated in most startups is like, for the most part, as a human organization endeavor, right? And I don't think people talk about it as much. Technology gets developed. Fundraising eventually gets happened. Customers come in if you have a useful product. But what makes company great is the people and how excited about it, how mission aligned they are. The feeling that you get every day you come to the work, it's not really about the task, at least for me, the tasks that I do. It's about who I'm doing it with. Who are the people that are going to sit down around the table? Am I going to get challenged by them? Am I going to have fun working with them? I think those are the stories that are often not talked about, but I think probably the most important stories in the company.
Were there any examples, or do you have any examples of your team, because you maybe did this right over time,
Yeah.
where your team was able to rise to an occasion or make something that you believed wouldn't be possible?
Yeah, I mean, exactly. We made that truck in 3 months. And we had like 2 or 3 systems we can allocate to it. Initially it was like 50 panels. We ended up narrowing down to 13 panels we needed it. The designs need to complete. People were working weekends, last minute making, decisions around, okay, what portion of a technology, like, okay, this portion of the feature, I'm just going to turn off and not work on and do a manual adjustment as opposed to relying on the tech stack. Yeah, I think, it was impossible to get a vehicle from design to full body panels manufactured and assembled in 3 months. And we all did it because we had a party coming up and we wanted to showcase the showcase the vehicle.
No better reason than a party coming up.
We need to make this happen for the party. And those are the moments that I think you're all going to remember, and they were not all pleasant, right? Some of it was pleasant, some of it was fights, some of it was, people, being frustrated. But then at the end, it all come together, right?
Yeah. Okay. Final question.
Yeah.
What's the hardest thing you've overcome?
Maybe I'll give you an indirect answer, and maybe we can kind of dive deeper a little bit, and I'll give you any more examples of it. I think startups are probably, building a startup is definitely one of the hardest things. I mean, I've been involved with 3 startups, and just the third one, first one I'm a CEO in, and it's definitely a hard thing to do. And I think the hard piece is around, it's always internal, right? It's like something inside, there's some resistance you have a lot of time around things. When you're wrong, accepting you're wrong. When something doesn't go your way, start pushing against it and figuring out what you got to do next. I think, I guess long story short is, I think the hardest things are those internal journeys that you go through. At the end of it, you become a better human as a result, but you feel a lot of resistance.
What were the biggest moments where you felt that resistance?
There are times where, a business deal doesn't come through, regardless of how hard you tried. You have 5-6 months of runway, and you really make sure that you need to do the next fundraise. Otherwise, you need to let big portion of the team go, and you really don't want to hit that deadline. And kind of you start going through the scenarios in your head, right? To be ready for it, to make all those decisions. I think those are the hard moments. A lot of them don't even happen, but like in your mind, you're there. You're making that decision. And you're like, okay, I need to be comfortable with it because it might happen in a month, right? And
you're running this like a whole bunch of universes may unfold and trying to figure out which one you're okay with.
It's funny, like, I did this. I had this professor at university that was teaching science of decision making, and one of the things he was teaching was um, you need to always be positive. Like you need to always think about the best outcome and be positive and send the positivity out there, and then you'll receive it. I think that didn't really work for me. So what I do, which is kind of the opposite of that, like I'll be like, assume the worst and live through the worst situation.
You've just mentally
And then
experienced it, and then
anything
afterwards
that
you're like,
happens
well,
is
it's already
great.
experienced it. So
Yeah, and anything
Yeah.
that happens is going to be a better situation. But those moments of mentally going through the worst case, I think is usually end up being the hardest moment. And nobody else also knows that's
No.
what's going on.
It's kind of funny. Like I was thinking about this last night before I went to bed, and I'm like, the number of things that I think about where I'm like afraid or worried. I don't even know if afraid is the right word,
Yeah.
but it's just like worried and thinking about it. And
Yeah.
I never actually tell anyone else. And
Yeah.
then I just figure it out the next morning
Yeah.
or a day or two later.
You just
Is
want to be
ridiculous.
prepared for it. Yeah.
Yeah. It's just ridiculous. And I think, people have this natural inclination to experience a loss twice as much as a gain.
Yeah.
And so we just by definition kind of have to like course correct for that.
Yeah.
Because obviously we're making progress. Like things are moving forward, and things aren't actually going to shit.
Yeah. Exactly. And also at the end of the day, I think, we're so lucky to be living in the United States, gone through great education, have the opportunity. I mean, like where else you have like venture capital, debt financing, amazing talent, and the culture that,
And then you get to like own your work and like own the reward or part of the reward.
Yeah, and culture that appreciates entrepreneurship and taking risks. At the end of the day, I mean, we're pretty lucky, and kind of keeping that in mind. That's like, even the worst case is probably better than most people in the world. It's a pretty empowering thing to think about.